Hello everyone, my name is Parker Wirtz, and I'm a junior at Gull Lake High School. I'm taking computer science and software engineering, and this is my Arduino microprocessors project. Me and my partner made a Majik trash can, spelled with a JK, because why not? But essentially, we used GitKraken as our commit area, and we set up our initial code shown up by this commit after learning about all sorts of Arduino stuff previously with breadboards and LEDs and whatnot, so we had like a basis of electronics and all that. I use a control K to get into this specific commit and check out our code here in GitKraken. This is exactly what is inside of our Arduino IDE, and I'm going to walk you through what is happening when our trash can activates. So, as you can see, when I wave my hand, the trash can opens up. This is because this micro or supersonic sensor right here is emitting sound waves that humans cannot hear. And when those sound waves get interrupted by obviously motion, it sends a signal to our Arduino board, to our Arduino board. We have it coded to then take power from this cord, which was plugged into the computer, and then send it to the servo or the motor to then pull and open the door. This specific set of code is just claiming like the start and stop and whatnot and what pins to activate. This specifically is giving us the pins to then activate so that we know which ones to power and whatnot so that our circuit will be completed. And then this is just delay and to loop it every time it sees motion or activity. And then this specifically is the delay to how long our servo or motor will keep the door open. And then it'll close it after that delay set. There's a few times. We also used GitHub as our online cloud. So just in case if we had to, which we actually did when we moved computers so that we could go downstairs for Innovation Day, and that way we could find it on the cloud and immediately download it so that we were ready to go. So just in here, I'm going to check out my Magic Trash Can branch, which is specifically the project they were doing, and then go into our sketch, and then enter the code. And as you can see right here, this is exactly what we had in the actual IDE here. Next, I would like to discuss some problems that we encountered during this project. This was our first prototype. We 3D printed it, and when we did it, or like when it was done with the printer, it came out fairly small. This meant we couldn't really fit any of the electronics in it, but it also allowed us to get the general shape that we wanted so that we could continue on in newer iterations and or prototypes. We then moved on to this cardboard one, which was a lot bigger and actually allowed us to put the technology inside of it. But the only thing that was really bad about this was that the motor was on the inside here. So the door opening was very inconsistent, where it would only open up sometimes to a perfect amount other times, and then like it would open crazy amounts other times. This leads us to our final project, at least right now, where we changed the motor's position to be up on top so that we would have more consistent openings and then it'd be better. Everything else was pretty much the same. I mean, we made it a little bit bigger so that you could fit more trash in it now that we knew exactly what we wanted. And we made specific cutouts for the supersonic sensor so that it was a little more visually appealing. This is a close-up of the motor up on top, held by zip ties, because this is a very cheap, made out of cardboard obviously, instead of a 3D printed material, because that is very costly, and for what we had, this is perfect for what we needed. Separately, this is the wiring. This is obviously unplugged from the computer, but the supersonic sensor here is wired to different pins on the Arduino board, which would then send its signals, causing the circuit to be completed and then powering the motor. For specifically Arduinos and circuitry, we learned all about cathodes and anodes, how that the cathode is negative and that the anode is positive. This would then allow us to apply resistors, specifically, I guess, calibrated or made sure that they resist the perfect amount with this device right down here, where we'd connect the two prongs, I guess, to each side of the resistor and made sure that the resistance was exactly how we needed it. It does this by measuring the voltage, sending a current in, and completing the circuit within the device, and it's actually pretty cool. All the resistors were up here in our tackle box of things. Other than that, this was an amazing project to be a part of, and I'd like to thank Joey for being there with me and helping me through everything. Thanks for watching, and I hope you can continue exploring my portfolio. Bye.